My name is Grzegorz. Today I'm with you thanks to Paweł and Piotrek. They invited me that I can say a few words about the singleton nightmare that we had in Curve. But before that, one more thing. As Piotrek mentioned, I organized Cocoheads in Kraków, so quite similar meetup. We mostly meet in the offices, so the old way, I think. But the hardest thing of doing that is, guess what?
Finding speakers.
Finding speakers, yes, Paweł knows. Finding the office is also hard lately because companies are, like cost cutting, etc. But still you can do it. But finding speakers is even harder. So let me say this. Do you know Friends? Anyone? Friends? Joey? You remember that he was writing a speech saying that love is about giving and receiving. So it's very nice to be here, to be a giver today. It's very nice that you are here, but remember, everyone needs givers that receivers can receive. Yeah, so remember about that. Okay? Before I start, few more words about who am I. I live in Kraków. I'm doing iOS development for over 8 years now. Counting over hours, it will be longer than that. My current salary service provider is Curve. I am in the mobile platform there. And what I do to reboard is I am daddy for 1.5 years. Understand. But also I am into cars, motorbike, MTB, electric cars, electromobility, etc. So if there is anything you want to reach me after about that, feel free. And I organize Cocoheads in Kraków, which is hard because we are looking for speakers. So if you want to say something. Okay, before we start, one puzzle. It was a year ago that I was doing the migration in our project from the Xcode 13 to Xcode 14. It was all good, all nice, until I started the app. And I saw this. Yeah. I guess everyone knows that. Very useful stack trace saying nothing. And it was just crashing at the application launch. What I was checking things, and I found that one of our frameworks, and we are using dynamic frameworks, is like collisioning with the system frameworks that Apple introduced with Xcode 14. And the question is, if you can guess which of them, one of them, is collisioning. Making crash. Because...
Smart rules.
No.
Account.
No.
Logging.
Close.
Networking. Config.
No.
Settings.
Settings. Yes. You can take one. Settings, yes. Settings was collisioning. The issue was that there was a public class in their settings and in our settings that was named, as I remember, the same. And it was referencing, so public class in settings, yeah? When you run the app, crash. What? I don't know about you, but I do that a lot in my job. Okay, so how the mobile app evolved? To understand the issue that we had, the nightmare, we need to understand how we get there. So, of course, you start with find new project. There is this greenfield opportunity that you take, and probably you will put most of the things into one application target. Yeah. You even add unit tests, everything is fine, the compiler is nice, Swift UI previews works, cool. Let's say there is a success story, yeah? Your company starts to grow, you need to add more and more code, more and more features, so you start extracting things, yeah? You will be focusing on the testability, and you will be extracting things probably like core things into separate frameworks, so networking, persistence, logging, maybe not settings yet. It's still fine, like the build time is still good, everything is fine, everyone is happy. then you get into the modularization. Yeah? Your company, there is another success story, there is more of you, more iOS engineers, maybe more Android. And you start extracting features into frameworks because you can see that those features also needs unit tests. Maybe you want to compile just that framework and see Swift UI previews, or you want to be fast with unit tests, you don't want to run the application. And the issues starts to pop up. The first issue will be, of course, with dependencies that you import by accident. So you have the feature 1 that only use networking and logging directly, yeah? But because it's also importing feature 2 that is using persistence, if you want to compile the feature 1, Xcode is also compiling persistence because there is this direct-indirect connection. And that's the issue, because if you do a small change here and you want to run the application, everything needs to be rebuilt. So the build time starts to increase, you will get frustrated, your CI/CD is taking longer and longer, every new feature is taking longer to add. It's still fine, trust me. In Curve, some of my preprocessors made the decision that there will be the intermediate layer called repository that is connecting all the things and exposing them to the feature frameworks. And trust me, it's a nightmare. Why is that? Because even a smaller change, the smallest change here, or to the model, anything, will, with the compilation, will enforce Xcode to recompile almost everything. And this is big. It takes a lot of time to compile. So you don't want that. And then adding new feature to the legacy project looks like that, yeah? You don't want that. So we noticed that there is this issue, we noticed the build time issue, we noticed the stability issue, we even noticed that actually with this, we are leaking domain between features, yeah? Because feature 1 domain is here, and the feature 3 can access that domain knowledge that you don't want to. So we decided to refine that. And we put some requirements. We started with that a framework should have a single responsibility. So that's the opposite of this repository framework. We wanted to break the vertical dependency of frameworks. Of course, it has to be continuous refactoring. Our product teams are working on stuff that we cannot just say to them, you should stop. We wanted to reduce the single feature framework build time. Of course, we wanted to have the compilation time safety access. The next thing, especially for our users, would be that we wanted to have the application startup time reduced. And last but not least, we are using Swift UI, and we want them to work as easy as possible. So we defined 2 different kinds of frameworks. One will be core frameworks. With example of analytics, we created another framework, dynamic one, that only exposes analytics API. Very close, very small framework that only exposes a protocol and the way to access that protocol. Okay? Then analytics, the implementation, is importing that and implement the heart of that. In the application, we do the wiring in the launch time, and under the hood, analytics probably is importing extra SDK, Firebase Analytics, Snowplow, whatever you're using. Yeah? That's the core framework. What about the feature frameworks? They are more complex. With the example of authentication, because authentication is used across the app in multiple frameworks. So for example, when the application launches, you start with the authentication. But from the settings module, you have the option to log out the user, yeah? So that's also part of the authentication. So authentication exposes those things with the authentication API. Authentication implementation has all of the implementation that is needed, importing this API and implementing it, but it's also importing other API frameworks. which compile very fast and has no underlying dependencies. Yeah? And then in the application, we wire all of that. So how our application looks like is that we have two buckets of things. One is core frameworks, and the second bucket is like feature frameworks. Nothing like that, as simple as it can be. Okay, code, how we did it. So doing the code, we were basing on this factory repository. You can check that. It's open source, so you can use that. I actually enhance you. We decided to write our own implementation of that based on the factory. So we added few simple things. One will be the structure of the factory that exposes the service itself. With the init, you can define the scope and the closure that returns the service. There is a call as function. Thanks to that, we can easily access this service, not calling like registration, factory.registration, just calling a function. The next thing we defined was the lookup container. So whatever you expose with this API module, it will be in the lookup container, because at the beginning, at the compilation, this container is empty. So there is underlying container, yeah, of the type of any container. Then you have the public function to inject that container, and you have the dynamic member lookup to access the elements in that container. Thanks to that, we can access container.analytics service. You will see in the example later on. Okay, so let's see call module code. Based on the networking, because we will do networking, we defined that the networking service is only exposing one or few functions. One is to send the API request. This API request structure is defined in the API module, as you can see here. It's taking the decoding strategy as the argument, and it returns the decodable model. To handle, that's important, default parameters, default arguments, we decided to go with the extension in this API module to save ourselves a little of code. So that was the service itself, and this is the container definition. Yeah. So here we are initializing the public container that we'll be using to interact with the networking service. Here is the networking service that at the beginning is empty, as mentioned, and there is public initializer that you can inject this networking service implementation. And then in our implementation side, as you can see, it's networking source. We are injecting actually shared session manager. And here we are using the old singleton nightmare solution still, because we wanted to have this continuity. That actually we are exposing the same session manager that is still being used in other legacy part of the code, only covered with the networking service protocol. And the wiring in the application delegate, very simple. You can enhance some tool to do that code that you don't need to rely on that, doing that manually. You can do sorcery or anything else, SwiftGen, whatever you need. Okay, that was the code of the core module. Let's see how we implemented one of the feature modules. Based on the authentication module, we expose the authentication service that is showing two things: if the application is unlocked, if user is multi-factor authenticated. And then the implementation is very simple. We have this very simple struct that holds those. Once again, we define the container. That is the lookup container of the authentication module. And this exposes the authentication coordinator and authentication service. And when we add new container, of course, we need to remember about the wiring. What we did in our case, we also added a danger check. So when there is a new merge request and someone touch container file, we are asking if you did the injection. Yeah, there is a message on the merge request. Intermission. You know this guy?
No.
He was in Krakow yesterday. Donald Trump. Actually, I am reading his biography right now. So his first company he did was Zip2. It was like Google Maps connected with Panorama Film. So when he did exit of that, he just earned $22 million. His brother earned $15. That's just enhancement to do your applications as Pavel do. I hope you will sell for 22 million.
I don't think so.
So do you know why he looks younger now?
He stopped programming.
Money.
No, he stopped programming. One coupon. Okay, how we are using this? Yes, based on the online verification interceptor. This is a very simple class that is intercepting the passcode verification in our code. As you can see, we are importing the logging API and the networking API. This is very important. You cannot import the implementation, yeah, because if so, you are still in the same compilation issue. Then we are using these lazy injected property wrappers. Thanks to that, this container service will be only extracted when it's being used. Very nice syntactic sugar that you can and you should use with Swift. And then when we are using that in the networking service, there is the send method. We are sending a request, and as you can see, there is not even a type passing like ask something because it's matching the return type. Very nice. And then if something went wrong, we are just logging what went wrong. That is one example of usage. Because our application is quite heavy and we have some static context and static functions and maybe even Objective-C functions, etc. You can also interact with the service just like that, call as function, yeah? You have the container, logging service. Notice that there is no module name before the container. And it's even better, even if you are importing here logging API and the networking API, you don't need to specify if logging service is in the logging API, networking is in the networking API, because Swift will manage automatically the namespacing. That's very nice. And the last usage is just typical dependency injection via the initializer. Okay, everything is nice. How to unit test, yeah? As you can see, our application is using a lot of services. If someone is using the protocol of the networking services and wants to test if everything is okay, of course, it will be a nightmare in every unit test module to create a mock, yeah? Like a lot of duplication. So what we did is we used sorcery. Who knows sorcery? Nice. It's like template metaprogramming, or in other words, it's just like a code generator based on code. So we're using sorcery to automatically create those networking service mock or spy, as you name it. And every function has this public function helpers that you can define the return value, you can intercept the request, you can see the calls count, and you have some function implementation. As you can see, it's a public class. So thanks to that, in the unit tests, even if you are using networking API, you don't do a testable import. And this is also very important. If you do a testable import of any other module that you are not testing, Xcode will compile that module again with test flags. Thanks to that, you can mock and interact with internal things in that module. We wanted to avoid that because if you once compiled networking API or networking, you don't want to recompile that for unit tests. Yeah? This is why the mock is public. And then you have the system under test, networking service mock, some stuff, and you just you initialize the suit. And because this lazy injected property wrapper allows to inject also from outside, we can just do that injection and write the test. Okay, so we can implement stuff, we can test that. It would be nice to run that, yeah? Who knows and use mini apps?
It's example apps, yeah, of the module.
Yeah, example, demo app, name it, 2 people. Do you like it?
Yeah, because otherwise it will be very hard to test feature quickly.
Okay, what about CI/CD? Is that application being validated when you create a merge request? If it's building?
No.
No. So with mini apps, we have this issue. You have, this is what this was used to was. There is this whole nightmare. There is a demo app. And let's say you want to do this, use it, this demo app, mini app, whatever. So you try to compile it, and then it's not compiling. Of course, someone did a change to this feature. This person was not using mini or demo apps, and it's not compiling. So just to start testing your stuff, you need to fix someone else's work, and you are just frustrated. And you just call someone, yeah, I'll find you. So our idea is, it's not being implemented yet, that our application will be super modular. All core services needs to be there, yeah? You need them to write a feature, yeah? But actually, when you are working on wallet, all other features can be mocked, yeah? Probably you would just have to, that this user settings API is returning empty view controller, empty view, empty service, mock service, whatever. So we want to write the code this way that you will be able to focus on a feature, yeah? And all other features wouldn't be compiled, wouldn't be even in your workspace, yeah? They will be ignored. So the results. Of course, we did that change to optimize the build time, especially, optimize how we interact with things, optimize the domain leaking. Let's focus on numbers. This is a core framework, build time. This is a cold build time. It was 12 seconds. I'm not sure what is that exactly. It's probably analytics. So previously, when you started the app, just to compile analytics, it was 12 seconds. And 2.5 second hot build if you didn't change anything, yeah? After the change and moving to core API framework, the cold build time is 2 seconds and the incremental build is 0.2. It's just like linking, nothing. Feature framework is of course longer. So let's say I want to run unit tests or Swift UI previews, cold build time 40 seconds almost, and the cold and incremental build 16 seconds. After we change that, because we are not importing so many things, cold build is 20 seconds and Swift UI preview change or something, unit test is only 6 seconds to build. And the application. So previously our application took 6 minutes to build. Why is that? Because we didn't descope the application that is reduced, yeah, to 1 and 20. It's because if you have all those frameworks that depends on each other, yeah, the lower will be, let's say, this logging, yeah. So Xcode needs to compile that logging framework before it even starts compiling feature A framework, yeah? Because the change we did, it can do that in parallel. Initially, almost every module in the app is being compiled at the same time, because later on it will be just linked, yeah? So we reduce the cold build time from 300 seconds to 120, and the cold incremental build from 210 seconds to 90. That's it. What tools we use? We use this factory pattern, sorcery, danger, static code analysis, Xcode frameworks. Yeah, we did. With Xcode frameworks, XC frameworks, in our application we have Realm. And if you are using Realm with Swift Package Manager, you need to use it as a code. You cannot use precompiled because Realm don't give that to you, even though they compile cartridge packages as XC frameworks. So we decided to just like tweak that a little, and we changed that there is extra Swift package manifest that exposes the XC framework, and that's also saving of like 40 seconds of build time. In Xcode, there is a very nice feature called Build with Timing Summary. You can check how your project is being built. It's split across your cores of your device, so you can see if like maybe first and the second core is overwhelmed and the rest is just resting. We are using Tourist for Xcode project generation. I use a lot of YouTube videos to see how how Spotify is doing that, Allegro, probably someone else, and ChatGPT. It's absolutely useless here. So you are asking ChatGPT, I have an issue that Realm enforced me to use Realm objects to interact with Realm. How to maintain that? And he's like, please use protocol with associated type. Awesome, yeah? So you start implementing, and of course this associated type will be Realm object at the end. So your API module would have to expose Realm, yeah? And you are writing to ChatGPT, but it's wrong, it's exposing Realm. Oh, sorry, I was wrong. And it was like, yeah, maybe talk with someone better. And that's it. Are there any questions? Yes.
So how long it took you to transition from this architecture with this central repository to this modern modularized?
So the question is how long it took me to refactor the whole application for this modularized repository pattern to this modularized pattern. So it was because in mobile platform it's just one person in my team, it's just me. Just creating those core modules took me, I think, around 5-6 months. Yeah. So every module, API module, protocol, implementation, unit tests, integrating that with the old implementation. That was the core module, and then I was involving other feature teams to refactor their job. So that was 6 months plus few more months, let's say 2, so 8 months. But that doesn't mean that the repository is fully killed in the application. There are still legacy patterns and legacy code that still use that, yeah? This repository is still there. So the answer is it's still not finished, yeah? Like every functionality is covered with the API right now, but we are redoing when we are, let's say, touching something, yeah?
So just follow-up question, do you still have some part of Objective-C code that interacts with this new model or with the old?
So the follow-up question is if we are still have Objective-C code that interact with new code or old one. Yes, we still do. We still have Objective-C parts, unfortunately. When there is interaction with this new code, we need to cover that with this NS class that expose Object-C parameter. Yeah. So there is a few connection spots. For example, with logging, yeah, because Objective-C still need to log things. But we are not actively refactoring this Objective-C because we are not touching them. Thank you.
Okay.
So I wonder, why did you decide to rewrite apply your own implementation of factory instead of using the factory itself?
Yes, very good question. So the question is why we decide to write our own implementation of factory. And we decided that because the factory is very good and our implementation is quite similar, but we added few our own things. For example, these property wrappers, lazy injected, they also have that, but they don't have this lookup containers. So of course we could just add that, but we wanted to have that fully on our own. Thank you. There was one more.
Yeah, I have one question. So what about the features development in the process you were refactoring this whole architecture? Was it like a feature development stopped for 6 months?
No. That was one of the requirements, yeah. So feature was still ongoing. The feature team is 5 iOS engineers right now. So it was this way that if there is no new implementation, they need to use the old one, and even they were still contributing to this repository, yeah. So this big repository was still growing at that time. When the new those core modules were popping, and we're ready to decide, okay, this is the way how we build feature modules, and it was tested also that it's okay. For example, the authentication module that is the feature module was refactored by me, not that I just asked someone to test that. There was like whatever is from now on, whatever someone is doing a new feature or even touching old one, they were obliged to use the new way of doing stuff. As well, we are using the feature teams. That's very important to refactor stuff. Yeah, So for example, this logging here, as you can guess, there is plenty of places that we log things. So whenever the feature team has some time to spare, they were jumping into that and they were doing refactoring. Thank you. Yes, one more question.
You said that you're using Danger to inform teammates about that they made some changes in the container. So that means that it's possible to make a mistake that won't appear in the compile time, right?
Yes. Oh, sorry. As mentioned, this wiring, it could be somehow auto-generated, but I didn't find a perfect way to do that. So it's still manual work. Because of that, we added this danger checks to do it right. And actually, we had one issue that someone did a hacky way of wiring, and there was a crash. Just in not in production. Yeah, it was caught quite fast. Yes, one more question.
Did you manage to reduce the launch time of the app?
So the question is if we managed to reduce the launch time. This is something I'm focusing right now on. So with the previous implementation, because those frameworks are imported in multiple places, core, they cannot be a static framework. And that means longer launch time. With the change I did, dynamic framework needs to be only the API, which is very small, and any implementation can be a static framework that will reduce the launch time. And I will be prototyping that, I think, this quarter. Okay, thank you everyone.